So once you have the Gradle, once you have download and then install the Gradle, just run the software. After that, click retrieve the data from Smart UMS. Here we have the data in order to answer question 10, Yellow Moranti assignment. So once you have clicked in download, simply drag the data that you have download into Gradle. Okay, and then after that you have this information. Click OK, click close. We have 3 variables, 2 independent, 1 dependent variables. In this case, we have this information. Simply click no, because our data uh, is cross-sectional. But of course, even if you declare that the data is time series, you will still have the same result. So just in my case, click no, and we have the 3 variables: height representing the dependent, diameter as well as bark thickness representing the independent variable. After that, we also have constant. Okay, constant representing a point when the regression line intersect with the height of Yellow Moranti. Yeah, in other words, constant term representing the height of Yellow Moranti when diameter and bark thickness are at 0. Okay, so click model, put, and then choose OLS, ordinary least square. So this is the regression model that we will use in order to identify the significance of the diameter as well as bark thickness in explaining the height of Yellow Moranti. We have the dependent variable, which is the height. So choose height, click this button, and then after that we also have the regresses. Regresses also represent the independent variables, diameter, and then the bark thickness. Click this green arrow. Okay, and no need for you to put constant. No need for you to put constant because it is automatically included. If you wanted to, say for example, you wanted to remove one of the variable, you can also do so. But in our case, we have to run the regression at once by using 2 independent variable in one go. So bark thickness. Okay, so after that you click OK, and then you have the result already. So this is the regression result. There are all of this information that you have over here on the screen are important, but our main focus will be on the coefficient and the p-value. Coefficient and p-value. So the coefficient or the beta represent a very important information. Yeah, so no need for you to look into the constant. The main focus will be on the diameter and then the bark thickness, because we wanted to see whether these 2 variables are significant or not. So we have the coefficient for the diameter of the tree, that is 1.53338. Remember, the coefficient can be negative, it can also be positive. In this case, it is positive. Both of them are positive. It means that there is a positive relationship between the diameter and bark thickness towards the height of Yellow Moranti. If it is negative, it means that there is a negative relationship between the variables. So here, the coefficient value is 1.53338. It means that when the diameter of the tree increases by 1 unit, then the height of Yellow Moranti will increase by 1.53338 unit. Same goes to the bark thickness. If the bark thickness increased by 1 unit, the height of Yellow Moranti will increase by 21.5592 unit. So another important information that we will be focusing on will be the p-value. It represents or shows this level of significance. In this case, we have a number of stars. For constant, we have 3 stars. It means that this constant is significant in explaining the height of Yellow Moranti at 1% significance level. If you have 2 stars, on the other hand, it means that the variable is significant in explaining the dependent variable at 5% significance level. For both the diameter and bark thickness, we have 1 star for each of them. It means that this diameter of the tree is significant in explaining the height of Yellow Moranti at 10% significance level. Remember, 3 stars means 1% significance level, 2 star means 5% significance level, and 1 star means 10% significance level. If you don't have any star, it means that the variable, that independent variable, is not significant in explaining the dependent variable at any significance level. So that's what it means. And apart from that, apart from the coefficient as well as the p-value, you also have to look into, our main focus will be on the adjusted r squared. Okay, this r squared, it can be adjusted r squared or r squared, but adjusted r squared is more ideal. So adjusted r squared shows percentage of the variance of the dependent variable that is explained by the independent variables. I repeat, the adjusted r squared represent percentage of the variance of the dependent variable that is explained by the independent variables. So here we have 49.66%. It means that 49.66% of the variance for the height of yellow Moranti are explained by the diameter as well as bark thickness of the yellow Moranti. So that's the thing that we need to know. If we refer back to the question, question 10a, state the multiple regression equation that shows the relationship with the height of yellow Moranti is treated as the dependent variable. In other words, you are required to draw the regression coefficient or regression function. So there are many ways on how to draw it. Okay, there are many ways on how to draw the regression equation, and this is the most simplest one. So the regression equation is y equal to a plus bx plus e. Y representing the dependent variable, a representing the coefficient, the constant term, b representing the beta, x representing the independent variable, and e representing the error term. So y in our case is the height of yellow Moranti, a representing the constant term, b, x representing the independent variable. Remember, we have two independent variables. That means we will have two bx's, b1x1 plus b2x2, then plus e representing the error term. So b1 represent the coefficient for the diameter of the yellow Moranti, x1 representing the diameter of yellow Moranti. Okay, b1 representing the coefficient, x1 representing the diameter of yellow Moranti, and then you will have b2x2. b2 representing the coefficient for the bark thickness, and x2 represent the bark thickness of yellow Moranti. So B2 represent coefficient, X2 represent the bark thickness of yellow Moranti, and then you also have to add E represent the error term. Error term records information that are not from the independent variable that also significant in explaining the independent variable. Yeah, so that is how we answer question 10a. Y equal to a plus b1x1 plus b2x2 plus e, where you have to indicate, you have to explain what each of these, what you call as a symbol represent, where y1 representing the height of yellow Moranti, a represent the constant term, b1 represent the coefficient for the diameter of yellow Moranti, x1 represent the diameter of yellow Moranti, b2 represent the bark thickness, coefficient for the bark thickness, x2 represent the bark thickness of yellow Moranti, and then e represent the constant, e represent the error term. So in order to answer question B, on the other hand, okay, here determine the multiple regression estimation based on least square method based on the regression model stated in A. So in order to answer question B, of course, you will have to refer back to this regression formula, and all that you have to do is to change the coefficient term in by referring to Gretel. Okay, by referring to Gretel. So y remain the same, but here our constant term will be different. Okay, you will change the a here into 69.8521, and then after that b1 you change it with 1.53338, and then b2 you change it with 21.5592. In order to answer question b, you don't have to include e, because when we do the regression, we assume that E is equal to 0. It means that there are no other important factors that are significant in explaining the height other than the diameter and then the bark thickness of the yellow Moranti. And all remain the same. Yeah, you have to explain what Y, X1, X2 represents. Okay, just change the A, B1, and B2. And remember that the data that I'm using here will be different than yours. So you cannot simply copy paste the answer that I have. You also have to run the regression on your own.